Hello everyone, my name is Paradesilaos, also known as Prot. In this video I want to talk to you about the basics of searching in Emacs. Searching and then searching and replacing. Those two go together because one feeds into the other. I want to provide you with an overview of what Emacs can do. This means that I will not go in depth on everything each individual functionality can accomplish, but rather provide you with the basics of what they do, the common day-to-day operations that they can fulfill, and then you can go and research the details on your own. This means that I will cover lots of different commands that Emacs provides out of the box. Towards the end of the video, I will also mention some external packages. I will not talk about them too much, but I will mention them because they enhance the functionality that is built into Emacs, and I think they are very useful to have, and personally I use them a lot. Let's start with the basics. Let's open a file, any file, it doesn't matter. Right now I am in the file manager of Emacs. And let me go to one file here. It's an Emacs Lisp file. And I want to perform the most basic search that Emacs provides for, which is by default bound to the key binding, control, and the letter S. You can see my key presses on the mode line. You can see it here, this indicator here. And next to them is the command that corresponds to the given key. So if you are using a different set of key bindings, you can still call the command by its name. This is I search forward. It means that I am performing an incremental search. And this is done from the point forward, meaning from the point and down towards the end of the file. So I will write, for example, G and then R and then A and start matching graph, the word graph. And you can see that I am on the given match right now, which is highlighted in yellow. And then the other matches are highlighted in a blue color. I can go from the current match to the next match by typing Control S again. And by typing Control S, I move from the one match to the one afterwards. I move one match forward. To perform the search in the opposite direction, let me cancel the search now. Control G to cancel. Control G generally is the key binding to cancel everything you are doing in Emacs. To perform a search in the opposite direction, but let me go to the end of the file to do that, I will type Control and R. Think of R as the reverse of the search that you were normally doing. So search in reverse. And I will again search for graph. You see now I perform the search from the end of the file and in reverse, meaning from the end towards the top. And Control R moves me backward by one. I can move back and forth with Control S and Control R regardless of how I started my search. As you can see over here, I am typing Control S and then Control R and Control S again. And this is the basic idea of how I search works. Once you have matched something and you have performed the search like this, you may decide that you want to edit your search in order to write some more, in order to refine it. You can do that by typing the meta and the letter E. The meta key and the letter E is to edit what you have already inputted in your search query over there in the mini buffer. And you can just continue typing. For example, I will type dash and then MA for magenta, like that. And I will type enter to confirm my match. And now I have just those two matches over here. I can type meta E again to edit by deleting some characters. And now I am back to the graph, what I was matching earlier. This is very good. Let's cancel it. And if you cancel just like that, Control G, you go back to the beginning of where you started the search. For you to actually land on the search, you have to type a character that exits the search normally. Let's see this right away. Let me go to the beginning of the buffer. And now I will search again for graph. And I will go a few matches further. And now I will type enter. By typing enter, I have confirmed my exit in a successful way. And you see now my cursor is where I left it. It didn't go back to the beginning or the end from where the search started. It stayed where the match was. I can control where I land, like here. You see where my cursor is? I am on the yellow match and my cursor is at the end of the match. But let's say I don't want to type enter to land on this spot. I want to exit the match successfully and move the cursor somewhere else. For example, I want to have the cursor to the beginning of the word. And I can accomplish this by using the motion Emacs has by default to move back a word, which is meta and the letter B in this case. Meta and the letter B here did two things. It performed the motion it normally does, and it also successfully exited iSearch, thus putting me exactly where I wanted to be. You can try this with all sorts of motions. Let's do again the graph. You can try this, for example, with meta and the letter M to go to the beginning of the indentation. Or you can try it with control and the letter E to go to the end of the line, and so on. The idea is that you can use a regular motion to move the cursor to where that motion would normally move it to and exit iSearch at once. And this is very powerful because it economizes on key presses. Once you have performed the search, and this was a successful search, you can quickly call it again by typing Control S and then Control S again. You see? Let me do it slowly. I do Control S and you see now it is empty. And I will type Control S once more and now it is searching for the last successful search, which was in this case the word graph. And I can continue moving like that. This is very useful when you have performed the search to go somewhere. Perhaps you made some edits, for example, some edits here, and then you want to go further down in your file, perhaps to make some more edits, and more edits here, for example, like that. And again, Control S, Control S. This also works in the opposite direction. Control R will repeat the search of the last successful search in the reverse order from where you are back to the top. This is the idea. Let me undo this. By default, the iSearch facility, whether we are talking about Control S or Control R, is only matching characters literally. It does not match a regular expression. Of course, you can change the default key bindings if you always do searches that are regular expression aware searches, then you can have those as Control S and Control R respectively. But with the default key bindings, if you want to perform a regex search, you have to do it with Control Meta and the letter S or the letter R. In this case, S and R have the same meaning they had before. Control Meta S will now, sorry, I didn't type it correctly. Control Meta S will now perform iSearch forward regex, as you can see on my mode line, and this is a regular expression aware search. Of course, if you type graph, it still matches it literally, because this is also a valid regular expression. But for example, what you can do is you can type dot and the star, which is the wildcard for all characters 0 or more times. And then you can have, for example, let's say 0-1 as a group here, and you can then edit this to match this, for example, like this. Or you can make it match, I can make it here, sorry, I did it wrong. you can edit the regular expression so that you match. Here what I did is I changed it so that it matches the first instance rather than the last instance, meaning that I made it non-greedy. Of course, I'm not here to talk about regular expressions right now. Maybe we can discuss this at another time. I also did a video in the past, which you can find in my backlog. The idea is that you can write a valid regular expression, and otherwise you can do Ctrl+S, Ctrl+R to move between the matches. Same idea as before. You can exit the regular expression search the same way you exit the regular I search. For example, I will do meta M here to go to the beginning of the indentation. And this is the idea, same in the opposite direction. And again, you can repeat the search by typing the keys that start the search twice. So Ctrl+Meta+S, Ctrl+Meta+S will repeat the last valid regex aware search, and the same for Ctrl+Meta+R, Ctrl+Meta+R. One of the nice features of iSearch is that it ties into other search commands that are built into Emacs. For example, one such search command is occur. Let me call it on its own for now. I will do it with Emacs first, and then the next time I will do it with a key binding. Emacs occur. O-C-C-U and the letter R. Occur. Emacs occur, and it is asking me for a regular expression. For now, I will just give it the word graph, the same I have been matching this whole time. And you see what occur does? It produces a standalone buffer and it places all the matches there. And I can peruse the contents of this buffer as I want. And I can see the line numbers where those matches are. And I can confirm those if I go to the actual buffer and enable line numbers. And I can see what those are, 119 and then 120. These look correct. They are the right numbers. And what you can do in the occur buffer, one of the features you can use it for, is to use it as a dynamically generated index where each of those lines is a node that you can visit right away by typing the return key. And by typing return, it will take you there right away. You see how this works. If you are in the occur buffer and you type N or P, this does it automatically, but it keeps focus in the occur buffer. You see how this works? I am typing P and N, and it changes the position in the actual buffer. This is very nice to have, especially when the matches are not clustered together the way they are here, but they are rather scattered across the lines of the file. Let's close occur right now. Let me do occur now again with a key binding. This one is bound to meta-S and the letter O. Meta-S and the letter O. And I will again search for the word graph. You will see that in my mini buffer prompt over there, graph is enclosed in square brackets. This means that the last successful search becomes the default search. So if I just type enter now without anything, it will repeat the last successful search, which is quite convenient in many cases. I type enter, and here it is. I did the same thing again like I did with Emacs occur. I did it with meta-S and the letter O. Let's close the occur buffer. Let's do it again one more time. When you are in the mini buffer like this and you have a default value, this is general, this is not specific to searching, but it is also convenient when you are performing a search. You have a default value in the mini buffer. And what you want is you want to bring it into the mini buffer in order to edit it, because you want to tweak it a bit. You don't want this exact value. You can do meta and the letter N to bring it into the mini buffer, and then, for example, I want to edit it a little bit like this, and then perform my search, and this gives me exactly what I asked it to search for. Let's close this, and now let's revisit iSearch. I want to do iSearch, and as I said, I wanted to connect it to other types of search. So I will do Control S, and then I will search for graph, just what I was doing the whole time. Now that I have matched my targets in a visual and interactive way, and I can see what I have here, I can store those in an occur buffer. I don't need to quit iSearch and then run occur. What I can rather do is take iSearch as it is and basically feed its matches, feed its output into occur directly. And I do that by calling occur from inside iSearch. You see, iSearch is active right now. I will use meta s and the letter O, and this did exactly what I described. It performed the iSearch, and then it took the match of iSearch and it gave it to occur, and then occur did what it does best, which is to show me this buffer here and then do what I wanted to do. Let's close this. The same idea with the regular expressions that you can do with iSearch, for example, graph, and then what I did earlier with 0 and 1, like that. And then if you do an occur, you are right there and you have your matches right away. Again, very nice to have. Let's dismiss the occur buffer. So far, I have told you about searching. These are very useful facilities. One point to note, which is not enabled by default, is when I am performing a search. Sorry, let me do it like this. When I am performing a search, notice here in the bottom part of my screen, in the area where the mini buffer is, I have a counter, and here it says 4 out of 13. And if I continue moving forward, the first number changes, the latter remains constant. The first number is where I am in the in the total number of searches, and the last number is the total number of searches. This is not enabled by default in Emacs, but you can easily toggle it on by, let me have these here because I have these already available for you. You can enable this by setting the iSearch lazy count to the T, to a non-nil value, that is, and then you can configure the prefix or the suffix format however you like it, and you can read the documentation about what those are. Personally, I like the prefix more, meaning that I want to have the counter before the text of the prompt rather than after the text of my search terms. But of course, this is a matter of preference. I will include those in the description that will be below the video when I post it on my website. So if you are watching this on the video hosting platform, I will include a link to my website where this publication will be present, and you can find the code from there. But let me not dwell on this. You can check the code on your own. Let me rather show you the other nice snippet that I have over there. By default, when you are doing an iSearch, a regular iSearch, there are cases where you want to match something without having to type out the whole match. For example, I want to match here BG, and then I want to match green, for example. You see, BG green. And this will do it like this. Sorry, I didn't mean to do it like that. BG, and then space, and then green. You see what I am matching? I am matching BG, everything in between, and then green. The reason this is done in that fashion is because I have configured iSearch to interpret the space, the literal space, as a non-greedy regular expression that matches every character between my two search terms. And this is done as I showed here. This is done with this option here. Again, I will include this in on my website, and you will find it from there. No need to get it from here. Of course, you can just pause the video and copy it if you want. But the idea is that this makes searching, like the regular searching, much more convenient. You don't have to type out a regular expression. Usually this is enough. For example, BG and then 0, and I match those. And even though this is not perfect, this usually is good enough for navigating a buffer. What I just did here is not applicable for the iSearch regex variant, so the one that is aware of regular expressions. Here, the space is literal, so if you type in a space, this is literal, and you see in this case, it is not matching anything, so I have to delete and then type the actual regular expression for it to work. You see how I am doing it here? And this is the same idea. It's good to have both because sometimes you want to match the space literally. Other times you want to match it in a flexible way so that you can move quickly to different parts of the buffer. And this covers it for searching. But I also want to show you how we can do search and replace. In Emacs, we have the query replace command, which is bound by default to meta and the %sign. With the standard QWERTY keyboard layout, you can type this by using your right hand to type meta shift and using your left hand to type the number 5. Just like this, query replace. And it is asking you for a word to match, and I will say graph in this case, and it is matching from where the cursor is and then down. Okay, so I will do that, and I will replace it with the word test, all capitals, just like this. And now it is ready to perform the replacement. You will notice though that it is not actually replacing. It has a question mark over there where I can press the question mark to get help. I encourage you to do this to see what your options are. For now, I will not cover all of those. You can check these at your own pace. But what I want to do instead is just do a query replace for graph like this, and then for test. And what I want to do now is type Y for yes, and this means that I am replacing this. And I do this one by one, which is quite powerful because there are cases where you don't want to actually replace it. So in that case, you type N, and yes and N, so Y and N. If you want to replace all of those at once, you can type the exclamation mark, which means yes to all, from point to the final match, yes to all of those. Perform the replacement outright. And this is exactly what it does. I will now undo my changes, and you will notice how the undo was done because the exclamation mark was interpreted as one motion. If I do undo, it also undoes it as one motion. Whereas the other two, I did them iteratively with yes and yes. So the undo is undo and undo. And this is again very, very convenient because it understands the steps you performed, the steps you followed, and so you can roll back those steps one by one. Very nice to have. Query replace also has a regex aware variant where you can do, for example, graph and then what I was doing earlier, just like that. And then it's the same idea. You can replace this with test and you can say yes or no and yes to all. Same idea as before, the same functionality. When you do a query replace like this, you have in square brackets the last successful query replace that you perform. And you can bring it into focus with, let me do it again, with meta n or meta p. and you can cycle between them just like that. And you will notice that it has not just the first input, but also the second input. So it has your target and its substitute, just like that. And you can just repeat your query and replace while you are at it like that. What I said earlier about iSearch to occur also applies to query replace. Let me use iSearch here to match a word, just like that. And I will move around a little bit with iSearch. And now I decide that from this point onward, I want to perform a query replace. I just type the key binding for query replace, and now I am ready to replace the text that I was matching, meaning the word graph, with whatever I give it here, which will be the word test. And again, the same functionality, just like that. Okay? Same idea. So you can do it on its own, you can do it from iSearch, and this is very, very nice. Query replace is especially helpful when you want to perform an advanced replacement, because you can rearrange the order of regex groups. Let me show you what I mean. But let's do it with iSearch, okay? I will use the iSearch regular expression variant. And now I will start typing a regular expression for one group. This will be BG. And in Emacs regular expressions, you scrape the groups with the backslash and then the parenthesis for the group matching. So I have that, and I will continue typing. The second group is, sorry, I want to edit it. The second group is graph. Let me do it like this. The third group is something that is indeterminate. It is any text in a non-greedy way until the dash. And then the last group, just like that, it is 0 or 1, and it's only matched one time. You see what I am matching now? I am matching those groups. The colored groups, except for the yellow parts. The yellow parts are not groups. The others, the green and the purple, are groups. And what I want to do now, of course I can use this iSearch to move around as I have already demonstrated, but what I can actually do now is I can feed this into query replace. Query replace, when it is regex aware, I think I didn't mention that earlier, it is control meta and the percent sign, okay? Whereas it is control meta and the percent sign, whereas the regular query replace is meta and the percent sign. But when you do an iSearch that is regex aware, if you do meta and the percent, so the regular query replace, it will still be aware of the regular expression syntax. So you don't need to type the explicitly regex aware query replace, just for you to know. So I will do meta and the percent sign, and you see now I am matching the regex there, and I can replace it with something. As I said, I want to rearrange the groups that I matched. Let's say that I want BG graph red 0 to be BG, then red, then graph, and then 0. Or I can have it the number, and then let's do it like this. I want to have the number, which is the fourth group. I give the number of the group with a backslash in order to tell Emacs that this is not a literal number. This is actually the group that you should put here. So number 4 here, the number 4 group, will be replaced with 0 or 1 the way I was matching it earlier. So I want to have the number first, then I want to have the first group, which was BG, then I want to have the third group, which was the hue, the name of the hue, and then I want to have the second group, just like that, because this is what I want to do. Once I have this in place, I can type enter and perform the replacements the way you do with query replace, yes or no, and I will do no a few times just for you to see, and the exclamation mark, and you see how this worked? 0 and 1, BG, the name of the hue, and graph you can see that this was a very powerful operation. I rearranged text in a manner that is efficient, in a manner that makes me feel great about using this functionality. And I did it by combining the interactivity of iSearch with the functionality of query replace. I think this is very nice to have. Let's go back to occur, because occur is not just for viewing matches, it is also meant to collect matches in a buffer and then use that buffer as your point of entry to perform replacements. I will now search for all instances of red. So I will run an occur for red. Unlike iSearch and query replace, by the way, I forgot to mention this earlier, occur operates on the entirety of the buffer, of the visible portion of the buffer. So it doesn't matter where you are and below, it will match everything. So I am matching all instances of red here. Let's have it like this. Let me go to the file here. And maybe I can move it this way so that it is easier for you to see what I am doing. So I have matched several instances of red over here in this occur buffer, and I want to perform a replacement using the occur buffer. I don't want to search in the file. I want to have the occur buffer because this has removed all the text that is not relevant for me, and it only shows me the text that is actually pertinent to what I am now doing. You can edit the occur buffer by typing the letter E, and by typing E, this activates the occur edit mode. This buffer is now editable, and I can go and perform an edit here, and I will say test. You see, I am editing the buffer to my right, and you will see on the buffer on the left, it changed focus and you can see the text over there, right? So you can do this. I will perform a query replace here now, and I will say I want to replace red with red and test, just like that. And yes, 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 no, 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 and then exclamation mark for yes. And you will see that every instance that had a match has been replaced the way I want it. If I do Control C here, I am now terminating the editable occur buffer, and this is again a buffer that is used for navigation purposes the way I demonstrated earlier. Okay? But let me undo all the changes here, and let me actually revert the buffer just like that so that I have all my changes be undone at once. And this is occur. Occur, of course, can be used not just with query replace. You can use it, as I already demonstrated, with any command that you have over there. Maybe I can put occur on the side here. You can use, so I will use the editable occur, and now I want to record the keyboard macro just because I can. I will start recording a keyboard macro, and what this keyboard macro does is actually, let me not make the occur buffer editable. Let's use it a different way here, because I already showed you the editable occur buffer, but let's now use the occur buffer as an index, just as an index. So I will start recording a macro, and I will use the occur buffer as an index to move to where the match is. So I start on the given line, I type enter. This moves me to the place where the match is. And because of the specific replacement I want to do here, I want to go to the end of the line and write a comment here, comment testing, whatever, because this is what I want to do in my edit. So I started from the occur buffer, I typed enter, I moved here, I went to the end of the line, inserted a comment, and now I want to go back to the occur window and go one down and close the, terminate rather, the keyboard macro over there. And now I will play back the keyboard macro a few times and you see what it is doing over there. It it did exactly what I wanted it to do. And of course I can move down a few lines and then repeat the keyboard macro over there, and just like that I was able to perform my replacements using occur to my advantage, and then the editing facilities of Emacs in general. These are all very powerful, and these do not exhaust what we can do in Emacs, but they already show you a lot of what we can do with it. Let me now go to the directory view over here. This is the directory editor of Emacs. It's called dired or dred or dred, depending on how you want to pronounce it. But whatever you do, make sure you use this, because this is also very powerful, and I will talk about it in a future video. Now I am in the dred or dired buffer, and what I want to do is I want to perform a grep. Grep is the standard Unix program for searching file contents, and there is an Emacs interface for it which will search file contents and put them in an Emacs buffer. And then we can use that Emacs buffer the same way we use the occur buffer. And let's see this in action. Emacs grep. I will do this. This assumes, of course, that you know how to use grep on the command line. I won't tell you everything about this here, but I want to search for graph, and then I want to match every file that is ending with theme.el, just like this. So I don't want to match the readme, I don't want to match the contrast ratios.org, I only want to match the -theme.el files. So I will type enter, and this has performed. Let's put this again in this window. Sorry, let me put it in this window, and just like this. This has matched the graph in all the files. You can see f-autumn theme, f-bio theme, f-cherie theme, and f-cypress, and so on for all my themes over here. By the way, the f-themes is one of my many packages for Emacs. And I have matched it over here, but let's go to the grep buffer over here. And if I do N and P, the same way I was using it in the occur buffer, it will move the searches. Notice that I am in the f-bio theme, okay? And you can see the name of f-bio over there. If I continue there, it moves to f-cherie. You see it? Just like that. And if I go back, it goes back to f-bio and again f-cherie. And the idea with grep here is that it basically opens, it visits the file in an Emacs buffer. And of course it is showing you the match over there. So you can use this as an index the same way we do with occur, and you can perform a keyboard macro from here, and that will be just fine to perform the replacements in the actual files. However, there is a package. Let me go to the scratch buffer. There is a package called wgrep. Wgrep. I strongly encourage you to install this package. It makes the grep buffers editable. It makes the grep buffers editable. So make sure to install this package. And let's go now to the grep buffer over here. Let's go to the beginning of the buffer. And you toggle the read-only state of the buffer, so you make it editable with Ctrl+X, Ctrl+Q. And you will notice here that it says press Ctrl+X, Ctrl+S when finished, or Ctrl+C, Ctrl+K to abort changes. They don't mention it here, but Ctrl+C, Ctrl+C also works. So what I want to do now, I have made this editable, and I want to perform a query replace for graph and replace it with test. And this is the same idea with query replace. I do it to all of them just like that with the exclamation mark. And then to confirm, I will type Ctrl+C, Ctrl+C, and this has performed the edits in all those files. And again, this is a regular grep buffer now, which is used for an index. Let's visit the changes here to see them actually, if it happened. You see, it has performed the changes over there, and I have lots of changes to consider. But let me actually undo all those changes. I don't want to have real changes written to my files, but I wanted to show you the facility of grep. There are lots of different types of grep in Emacs. There is the regular grep, there is lgrep, there is rgrep, but fundamentally they all do the same thing. I don't want to go into the technicalities of each of them, but just to give you an overview of how powerful Emacs is and how you can use it to your advantage. Let's go back to this file over here, and let me close this video, conclude this video with a few words about the excellent consult package. There is the consult package. Install this package. It provides lots of useful commands that enhance the mini buffer experience of Emacs, e.g. for searching lines, headings, like that. So the consult package. Again, I will include this on my website. Let's use now, I will do it with Emacs, consult-line. This is like iSearch, but now it is matching things like this, because I am not using vertical right now. I have to use the default completions buffer. But you can see how I am matching things. I have a visual view like that, and this is very convenient because let me do it again. Graph. I have a visual representation like this, but what consult does is it also shows me a preview. So if I move to the next match, it actually switches the underlying file to show me where I am. You see? It is moving the file together with my motions over there. And this is very wonderful because now you get a sense of the context of your match. This is especially useful when you have a big file and your matches are not clustered together. They are scattered across the lines of the file. Consult has other very nice functionality, very nice search commands. But let me go to the org file here. And this is the manual of the F-themes. And you will see that I have lots of headings here. I want to do, actually let me enable Vertigo for now. When I do, in my own sessions, I use Vertigo actually. Vertigo is what enables, sorry, let's have it here. It's what enables this vertical view of the mini buffer so you can see the matches right away. Let me show you then. I want to now search for a heading. I don't want to use iSearch for this. For example, if I search for configuration with iSearch, it matches the contents as well, but I only care about headings right now. So I will cancel this, and I will do Emacs consult outline, just like this, consult outline. And if I do config, you see I have sample configuration and configure, and iSearch, and sorry, rather, consult outline has the preview functionality as well. And then you type enter, you just go where you need to be, just like that. Let's go to a document that is some code, and let's do here again the consult outline works here because it matches all the outlines of the major mode you are in, but it depends on the major mode. If you are in a programming mode, you are most likely going to prefer the consult-i menu, which is, as you can see here, a semantically relevant grouping of headings, of points of interest in your file. And you can see what I have here. I have the variables, and then I have the functions further below and stuff like that. What you can do with consult is you can limit the search to the given type. For example, if I type the letter V and space, now I have limited it, I have narrowed the search to only variables. So if I search for, I don't know, load, for example, this is only matching variables that include the word load. If I delete backward, I will eventually undo the narrowing. And I can add another narrowing, F and space for functions. And if I do load now, you see I have different matches just like that. And I can go where I need to be and type enter, and very quickly I was able to navigate this file and go exactly where I needed to go. Consult has also a grep facility. Let's be here. Consult grep. Emacs consult grep. There is also the rip grep equivalent in case you are using the rip grep executable, but that is a technicality we don't need to go into right now. Emacs consult grep, and you type enter, and this allows you now to search in two ways. Let me explain. You will see that there is the hash sign over there. Because grep is not an Emacs command, it is a Unix, a Linux command, or on your operating system, whatever. You have to initiate the command from inside the Emacs. So what consult does, the text you have inside of the columns here, inside of the hashes, it will send it to grep, and it will run grep in a non-blocking way, in an asynchronous way. So matches will be coming in as you keep typing here. In this case, it's a small search and it's quick, so it matched everything right away, but you may search for something that goes through hundreds of files and has thousands of matches, so you will see results coming in, and you will see the counter here going up as the seconds pass. But what is inside of the hashes is sent to grep. And then what you type after the hashes is what you use to filter the mini buffer. For example, I will do red, and now I have matched everything that is red. I can do, for example, graph and then dash red, and now I match everything that includes graph and red like this. This will use your completion styles in the mini buffer, and so it will match everything just like that. So you have to check your completion styles, but this is not something to go into right now. The idea is that you can bring the full power of the Emacs mini buffer to this interface and match what you are searching for very efficiently and very quickly. Finally, the very last thing, there is another package called Embark, and let me write it here, which is another excellent package. Embark, and install this package. It allows you to perform context sensitive actions using a prompt and then a key selection interface. A key /action selection interface, just like this. Again, I will have all this on my website. Let's be here and let's use consult grep. And what I will do now is that I will invoke Embark, and you will see here Embark gives me some relevant actions. It is not shown there because I am hiding it by default, but with the capital E, I can export the searches from the consult interface to a regular grep buffer, and as you can understand, this is used the same way I demonstrated earlier. You can use it as an index. You can also use it to perform a query replace, or generally to make this an editable buffer and perform your edits just like that. And this gives you an overview, folks, of what you can do. You can very efficiently with Emacs replace thousands of matches in basically seconds. I have used this many times throughout the years with Emacs, and I think it is one of the best facilities that exists in everything, in all programs. Basically, it is very, very, very nice. I like it a lot, and I think it is very convenient, very powerful, and not that difficult to use once you put the pieces together. The very last thing, which is not a search per se, but it is actually convenient. Let's go to the manual here, because it has lots of code, lots of text here. Imagine now you are in a document like this. It has lots of text, and you want to search for something like this, for example, package, and you want all instances of package to be highlighted because it is for you relevant. You are doing some reading and you want them to be highlighted whenever you encounter them in the file. What you can do after you have done the iSearch is you can type meta s h and the letter r. Meta s h and the letter r means to highlight the regular expression. In this case, it will highlight the word you were already matching with iSearch. And now what it is asking you for is a face to use, and you get a preview of the faces if you have the relevant mini buffer packages installed. But for example, let's use high yellow here. I will type enter, and you see those are now yellow. Very good. Let me do, for example, again the same idea. And now I won't use iSearch though. I will type meta s h and the letter r. And now I will search for Git, just like this. And now I will use the blue color. And you see what I did here? I highlighted those matches as well. iSearch feeds into meta s, h, and the letter r the same way it feeds into occur and query replace, just like that. If you want to unhighlight, you do meta s, h, and the letter u. Sorry, I typed I. Meta s, h, and the letter u. And it tells you which one you want to unhighlight, and I can select them just like that. And there you have it, folks. This is all for today. Thank you very much for your attention. This was an overview of searching in Emacs, searching and replacing. Searching and replacing in a very efficient way. So thank you very much for your attention. There are many ways you can combine these, and there are more that I did not show, but I am sure you get the gist of it, and then you can find the others as you get to use Emacs more. Thank you very much for your attention. Take care. Goodbye for now.